Look up at the night sky on a clear evening. Every star you see, every faint point of light, is a furnace forging the very elements that make up your body. Carl Sagan understood this profound truth better than perhaps anyone in the 20th century. When he spoke those now legendary words, "We are made of star stuff," he was not speaking metaphorically. He was teaching us a fundamental truth about our cosmic origins. The calcium in your bones, the iron in your blood, the oxygen you breathe in this very moment, all of it was manufactured in the nuclear fires of stars that lived and died billions of years ago, long before our sun ever ignited. Now, traveling through the darkness between stars, comes an object that embodies this connection in the most literal way imaginable. It is called 3I Atlas, and it is something Sagan dreamed about, but never lived to see. This is the third confirmed interstellar object ever detected passing through our solar system, a cosmic wanderer carrying with it the actual star stuff of another stellar system. Not our atoms, but theirs. Not our chemistry, but the chemistry of a place so distant that light from their parent star may never reach us. 3I Atlas connects two regions of space that would otherwise remain forever separate, two islands in the cosmic ocean that have found a bridge. Carl Sagan spent his life helping humanity understand our place in this vast universe. In Cosmos, in Pale Blue Dot, in everything he wrote and spoke, there was this recurring theme. We are connected to the cosmos. We are not separate from it. We are the universe becoming aware of itself. If you believe in continuing that mission of cosmic exploration and understanding, join us on this journey through space and time. Subscribe to keep learning about our place among the stars. So what would Sagan have seen in this visitor from beyond? The answer reveals something profound about the universality of physical laws and the interconnectedness of all matter in our galaxy. When astronomers at the Asteroid Terrestrial Impact Last Alert System discovered 3I Atlas in 2024, they immediately recognized something extraordinary. The object's trajectory showed it was not gravitationally bound to our sun. Its velocity exceeded what any object born in our solar system could achieve through gravitational interactions alone. The mathematics were clear. This object came from interstellar space, from a region of the galaxy shaped by a different star, governed by the same physics but expressing different chemistry. 3I Atlas is moving through our solar system at approximately 34 kilometers per second relative to the Sun. To put that in perspective, that is nearly 76,000 miles per hour. At that speed, you could circle Earth's equator in roughly 20 minutes. But 3I Atlas has been traveling for an unimaginably longer time. Based on its current trajectory and velocity, astronomers estimate this object has been wandering the galaxy for potentially millions of years, perhaps far longer. During that journey, it experienced conditions we can barely imagine, the cold of interstellar space, where temperatures hover just a few degrees above absolute zero, the faint radiation from distant stars, the occasional gravitational tug from passing stellar systems. Here is what fascinates scientists most. As 3I Atlas approaches our Sun, it is changing. Observations from ground-based telescopes show the object developing activity. It is brightening. Spectroscopic analysis reveals the signature of gases escaping from its surface. Dust particles are being liberated by the warming influence of sunlight. The object is developing a coma, that fuzzy envelope of gas and dust that surrounds active comets. Some observations even suggest the beginning of a tail, that magnificent feature that made comets objects of wonder and sometimes fear throughout human history. This behavior tells us something crucial. 3I Atlas is not a bare rock. It contains volatile materials, substances that evaporate when warmed, water ice likely, carbon monoxide and carbon dioxide possibly, complex organic molecules perhaps. These are the same materials that make up comets born in our own solar system, those icy wanderers from the Oort cloud or the Kuiper belt. The chemistry may differ in details, but the fundamental processes are universal. Sagan would have been deeply moved by this. In Cosmos, he wrote extensively about the universality of physical laws. The same forces that govern atoms on Earth govern them everywhere in the universe. Gravity works the same way billions of light years from here as it does in this room. The electromagnetic force that holds molecules together does not change from one galaxy to another. What 3I Atlas demonstrates is that the chemistry of planet and comet formation, those processes that led to Earth and everything living on it, operate throughout the galaxy. Other star systems create icy bodies just as ours does. They forge atoms in stellar cores just as our sun's predecessors did. Consider this perspective that Sagan loved to use, the cosmic calendar. If we compress the entire 13.8 billion year history of the universe into a single year, with the Big Bang occurring at midnight on January 1st, our sun does not form until September 1st. Earth coalesces shortly after. The first life appears in mid-September. Dinosaurs reign and vanish in the last week of December. All of recorded human history, everything from the first cities to this moment, occupies the final seconds before midnight on December 31st. In this calendar, 3I Atlas began its journey at some unknown date in the past. It might have been ejected from its birth system in October or in July, or even back in the spring of the cosmic year. While humans were just learning to make stone tools in the last minute of the cosmic year, 3I Atlas was already traveling through the dark. While we were building civilizations and writing poetry and launching telescopes, this object continued its silent voyage, carrying its cargo of foreign star stuff toward an appointment with our solar system. The physics of this encounter are elegant. 3I Atlas follows what is called a hyperbolic trajectory. Unlike the elliptical orbits of planets and most comets born here, a hyperbolic path is open. The object comes in, makes its closest approach to the sun, and then departs, never to return. Gravity bends its path but cannot capture it. Our sun's gravity well is not deep enough to hold something moving this fast. So 3I Atlas will swing around, perhaps picking up a tiny bit more velocity from the encounter, and then head back out into interstellar space, carrying with it solar photons and perhaps a few atoms from our solar system's dust, an exchange of materials between stellar neighborhoods. What Sagan understood, that we are only now confirming through objects like 3I Atlas, is that the galaxy is not a collection of isolated stellar systems. It is an ecosystem. Matter flows between stars. Objects are ejected from one system and captured by another. Interstellar clouds collapse to form new stars, incorporating atoms from previous generations. The iron in your blood was likely created in a supernova explosion. But which supernova? It could have been one that exploded 5 billion years ago just before our solar system formed, or it could have been from a star that died 8 billion years ago, with those atoms wandering the galaxy for 3 billion years before finding their way into the molecular cloud that became our sun. 3I Atlas represents this flow of matter in the most tangible way. We can point our telescopes at it. We can measure its spectrum and analyze its composition. We can watch it change as it responds to our sun's warmth. This is not abstract theory. This is a physical object from another stellar system that we can study directly. Sagan was a strong advocate for the search for extraterrestrial intelligence. He helped design the golden record that flew on the Voyager spacecraft, a message to any civilization that might someday intercept those probes. He worked on SETI, the search for extraterrestrial intelligence, believing that the universe was too vast and too old for Earth to be the only world bearing life and consciousness. But Sagan was also a rigorous scientist who understood the importance of evidence. He taught us that extraordinary claims require extraordinary evidence. So when we look at 3I Atlas, we must apply the same standard that Sagan would have demanded. What do we actually observe? We see an object displaying cometary activity. We see spectroscopic signatures consistent with sublimating ices. We see a trajectory that indicates interstellar origin. We see no evidence of artificial construction, no radio signals, no mathematical patterns in its motion. This appears to be a natural object, a comet or perhaps a transition object between comet and asteroid that formed in another star system and was gravitationally ejected into interstellar space. There are people on the internet who will claim more sensational things. They will say this object is a probe or a ship or a warning, or evidence of conspiracies. Sagan would have responded to such claims with patience and critical thinking. "Show me the evidence," he would say. "Not what you want to believe, but what the data actually demonstrates." Science is not about confirming our pre-existing beliefs. It is about following the evidence wherever it leads, even if it leads to conclusions less exciting than we hoped for. The actual story of 3I Atlas is exciting enough without embellishment. This is an object from another star system that we can study with our own instruments. Think about what that means. When spectroscopes break down the light reflected from 3I Atlas, they are analyzing photons that bounced off atoms forged in another stellar furnace. When radio telescopes track its position, they are measuring the gravitational influence of a body shaped by processes that occurred light years away. We are literally touching another star system through scientific observation. Sagan wrote in Pale Blue Dot that when Voyager 1 turned its camera back toward Earth from beyond Neptune, capturing that famous image of our world as a tiny pale blue dot suspended in a sunbeam, it reminded us of our cosmic context. From that distance, Earth has no special significance. You cannot see nations or boundaries. You cannot distinguish continents. All of human history occurred on that tiny pixel. All the wars and loves and discoveries and tragedies, everything. 3I Atlas offers a different perspective on cosmic context. From its point of view, as it travels through our solar system, it sees the Sun as one star among billions. Earth is even less significant from its perspective than it was in Voyager's image. To 3I Atlas, if objects could perceive, our solar system is just another gravitational field to navigate through, another star briefly warming its surface before it returns to the cold dark. But here is what makes this profound. We, living on that pale blue dot, can reach out with telescopes and mathematics and understand this visitor. We can track its motion, predict its path, analyze its composition, and place it in the context of galactic evolution. We are, as Sagan said, a way for the cosmos to know itself. Through human consciousness and scientific investigation, the universe has developed the capacity to study its own contents. 3I Atlas is not conscious of us, but we are conscious of it. We understand what it is and where it came from. We have extracted meaning from its presence. The detection of interstellar objects like 3I Atlas has only become possible in recent decades. Before the 1990s, we had no telescopes sensitive enough or systematic enough to spot these visitors. The first confirmed interstellar object was Oumuamua, detected in 2017. The second was 2I Borisov, found in 2019. Now we have 3I Atlas. As our survey telescopes improve, as facilities like the Vera C. Rubin Observatory come online with their ability to scan the entire visible sky every few nights, we will detect more of these travelers. Astronomers estimate that at any given time, there may be thousands of interstellar objects passing through the inner solar system. We have only just developed the eyes to see them. What would Sagan have thought about living in an era where we can detect and study visitors from other star systems? In 1980, when Cosmos first aired, such detections were purely theoretical. Scientists understood that gravitational interactions would eject comets and asteroids from planetary systems. They understood that space between stars was not truly empty, but contained wandering bodies. But no one had ever seen one. No telescope had ever caught such an object in the act of passing through our neighborhood. Today, we live in an era that Sagan could only imagine. The James Webb Space Telescope, which became operational in 2022, has sensitivity and resolution far beyond what existed in Sagan's lifetime. Ground-based telescopes have grown larger and more sophisticated. Our ability to detect faint objects moving quickly across the sky has improved by orders of magnitude. This is the continuation of a journey that started when early humans first looked up and wondered about the stars. That wondering led to naming constellations, then to tracking planetary motions, then to understanding that Earth orbits the Sun, then to discovering that the Sun is one star in a vast galaxy, then to learning that galaxies are island universes scattered throughout an expanding cosmos. Now we are at the stage where we can track physical objects traveling between stars. The cosmic distance scale has collapsed in our understanding. We have gone from seeing stars as mysterious lights to understanding them as distant suns to now receiving actual samples of matter from their neighborhoods. When scientists analyze the spectrum of 3I Atlas, they are reading a chemical story written by another star. Different stars have different compositions depending on when they formed and from what material. Stars that formed early in the universe's history contain mostly hydrogen and helium, the primordial elements from the Big Bang. Stars that formed more recently, like our Sun, contain heavier elements forged in previous generations of stars. By studying the composition of interstellar objects, we can learn about the chemical evolution of different regions of the galaxy. Consider what Sagan taught us about stellar nucleosynthesis. In the cores of stars, hydrogen fuses into helium, releasing energy. That is the process that makes stars shine, the same process that warms Earth and makes life possible. In more massive stars, the process continues. Helium fuses into carbon, carbon into oxygen, oxygen into silicon, silicon into iron. Each step releases less energy until finally the star reaches iron. Iron fusion consumes energy rather than releasing it. At that point, massive stars collapse and explode as supernovae, scattering all those newly created elements into space. Those elements become part of the molecular clouds that birth new stars and planets. The atoms in 3I Atlas went through this process, but in a different stellar system. They were forged in a different star, scattered in a different supernova or planetary nebula, incorporated into a different molecular cloud, and eventually condensed into this small icy body. Now, by chance and gravitational mechanics, that body has found its way to us. We are literally examining the star stuff of another stellar neighborhood. This connects directly to Sagan's message about our cosmic origins. Every atom in your body, except for the hydrogen which dates to the Big Bang, was manufactured in stars. You are not merely in the universe. You are made of universe. The universe is not something foreign and external. It is what you are composed of. When you look at 3I Atlas, you are seeing family, distant family, formed under different conditions, but family nonetheless. The same physical processes that created the material in that comet created the material in your body. The same forces, the same quantum mechanics, the same nuclear physics. Sagan would have loved the profound simplicity of this truth. The universe is not divided into us and them here and there, Earth and space. It is all one system, connected through physics and chemistry, and the flow of matter over vast distances and timescales. 3I Atlas is not an alien invader in the fearful sense. It is a relative visiting from another branch of the cosmic family tree. As 3I Atlas makes its closest approach to the Sun and then departs, heading back out into the darkness, it will carry with it something new. Solar photons will have altered its surface chemistry slightly. A few atoms from the solar wind will have embedded themselves in its ices. Micrometeorites from our solar system might have struck its surface. So when 3I Atlas returns to interstellar space, it will not be quite the same object that entered. It will carry trace evidence of its passage through our stellar neighborhood. In hundreds of millions of years, if it encounters another star system, it will bring with it a tiny sample of our Sun's domain. This is how galaxies maintain chemical homogeneity. This is how elements spread. This is why, when we look at distant stars, we see the same elements we find on Earth, just in different proportions. The universe is constantly mixing and remixing its chemical inventory through mechanisms like gravitational ejection of comets, stellar winds, supernova explosions, and galactic tidal forces. 3I Atlas is one small example of a process that has been ongoing since the first stars formed over 13 billion years ago. Carl Sagan ended Cosmos with a vision of humanity's future among the stars. He spoke of generations yet unborn who would venture out from Earth, who would establish homes in the solar system and perhaps eventually travel to other stars. He believed that our destiny was tied to space, that we were unlikely to survive indefinitely if we remained confined to one world. Not because Earth was insufficient, but because cosmic threats like asteroid impacts or stellar evolution would eventually require us to become a multi-world species. Objects like 3I Atlas remind us that the galaxy is dynamic. Space is not static emptiness. It is filled with motion, with wandering bodies, with flowing matter and energy. Understanding these processes is part of learning to navigate the cosmos. Before we can travel to other stars, we must understand the environment between stars. We must learn what hazards exist, what resources might be available, what the actual conditions are in that vast dark ocean. In his final book, written as he battled the cancer that would take his life, Sagan reflected on the pale blue dot image and what it meant for human behavior. He wrote about the folly of nationalism, the absurdity of war, the fragility of the only home we have ever known. Looking at Earth from cosmic perspective, he argued, should humble us and make us more protective of our world and more kind to one another. There are no borders visible from space. There is only one world, precious and rare, floating in immensity. 3I Atlas offers another version of that humbling perspective. This object has been traveling for longer than human civilizations have existed. It has covered distances that would take our fastest spacecraft tens of thousands of years to traverse. It emerged from conditions we are only beginning to understand. And yet here it is. For a brief moment in cosmic history, its path intersects with ours. We have the extraordinary privilege of witnessing its passage and learning from it. Sagan taught us that we are star stuff. 3I Atlas demonstrates that truth by carrying star stuff from another region of the galaxy into our view. It connects us physically to the wider cosmos in a way that is impossible to ignore. When you think about this object, you are thinking about atoms forged in another stellar furnace, shaped by another star's gravity, traveling across distances measured in parsecs. You are contemplating the deep unity of cosmic matter and energy. This is Carl Sagan's legacy, not just the specific facts he taught, though those were important. Not just the television series or the books, though those reached millions. His legacy is a way of thinking about our place in the universe, a perspective that combines scientific rigor with spiritual awe. An understanding that we are simultaneously insignificant on cosmic scales and extraordinarily precious because we represent the universe's capacity for self-reflection. We are how the cosmos has come to know itself, and that makes us valuable beyond measure. As 3I Atlas continues its journey back into the interstellar void, it leaves us with questions to ponder. How many other such objects are traveling through the galaxy unobserved? How many star systems have contributed wanderers to the cosmic ocean? Could any of these objects carry something even more interesting than ice and rock? Could any carry preserved organic molecules from another world, or even evidence of past life? These questions remain open. The data we collect from each interstellar visitor brings us closer to answers. We are living in a golden age of discovery that Sagan would have celebrated. Every week brings new exoplanet discoveries, new insights into galactic structure, new observations of distant quasars and black holes and colliding galaxies. The universe is revealing itself to us in unprecedented detail, and occasionally it sends us a tangible messenger like 3I Atlas, a physical object we can track and study and learn from. Continue Carl Sagan's mission of cosmic exploration by staying curious about the universe. Learn about the latest discoveries. Question what you hear, but remain open to evidence. Understand that science is not about certainty, but about following the data and refining our models. Look up at the night sky and remember that you are made of the same stuff as those distant stars. You are not separate from the cosmos. You are cosmos experiencing itself. That is Carl Sagan's greatest gift to us, that perspective of cosmic connection and human responsibility. 3I Atlas traveled across the galaxy to remind us of that truth.